Hello everyone, my name is Francis and this is my walkthrough of my application and a technical description of my Python code. So let's start off with Math Quiz application. This Python program is a math quiz application built using tkinter library for its graphical user interface, or the GUI. The program presents users with randomly generated math problems, allowing them to select difficulty level and track their progress throughout the quiz. The user is asked 10 questions, with each problem randomly generated based on the selected difficulty, which could be easy or single digit numbers, moderate double digit numbers, or advanced 4-digit numbers. The user's answer is compared to the correct answer, and if it's correct, they earn points. So now let's head on to the quiz or the features of my math quiz application. The quiz also features feedback on whether the answer is correct or incorrect using pop up messages at the end of the quiz, and final score is displayed along with the grade based on the score, like A plus, A, B, C, and so on and so forth. The core logic includes functions like random integer, which generates random numbers based on the difficulty level. This one, this part of the code. It uses if else statement and elif statements. Uh, the side operation which randomly chooses between addition or subtraction. Uh, and the program uses the message block module from Thinkinter to show error messages and display final results. And moreover, to the functions, um, it has display problem function which generates and display new math problem by selecting random numbers and an operation which are then displayed in the GUI. It also clears any previous user input from the answer field. Uh, Check answer function is responsible for checking the user's answer. It compares the answer entered by the user with the correct answer based on the operation addition or subtraction. If the user's answer is correct, they earn 10 points. If it's incorrect, are asked to try again and they receive 5 points if their answer is correct in their second attempt. The answer is updated and message is displayed indicating whether the answer is correct or incorrect. For display results function, once the user has answered all 10 questions, this function calculates, displays the final score along with the corresponding grade A plus A, B, and so on and so forth in a pop up message. Moving on to the design of the application, the GUI layout consists of a window with a title, difficulty level drop down, um, area to display math problems, an input field for the user's answer, this one, and this is the difficulty level. And the window is designed with a soft color scheme to provide an engaging user experience. The application uses a loop to generate a new question after each answer, and after that question, it displays the user's score and grade, then closes the application. Overall, the program is designed to make learning math more interactive and fun by integrating graphical elements with core functionality for calculating and verifying answers. It's a simple yet effective way to practice basic arithmetic while keeping the user engaged with immediate feedback. So I have already did the answering part before I recorded. So this will be the ninth attempt of answering this. Uh, 9 plus 4 plus 2, 6. As you can see, it shows if it's correct or not, and then it shows the final score or the final grade also, which I got 90 out of 100, and I got A plus. And that would be it for math quiz. So let's head on to Alexa. Alexa tells me a joke. Moving on to the Joke Teller app, this Python program creates a GUI based Joke Teller app where users can see random joke setups and reveal their punchlines interactively. The key components of the program include file handling, random selection of jokes, and dynamic interactions with the user throughout the graphical interface. Moving on with the functions of this app, loading jokes. Load jokes file name function is responsible for loading jokes from the text file, and the jokes are consumed to be in specific format, assumed in specific format where each line contains a joke setup and a punchline separated by a question mark. Displaying jokes. The display joke function picks a random joke from the list, splits the joke into the setup and punchline, and displays the setup in the GUI. It updates the joke text variable to show the setup and clears the punchline text. For revealing the punchline, function is called when the user wants to see the punchline. If there is a current joke, it splits it at the question mark and displays the punchline. If no joke is selected, it shows a message box alerting the user that there is no joke being revealed. As for the design, the joke teller GUI has 600 over 500 pixel window with a white background. The main feature a the main features a joke card with a orange background showing the setup and the punchline of the joke. Below the card, two buttons which are next joke and reveal punchline allows the users to interact. A footer with the message laughter is the best medicine is shown at the bottom in purple. The layout is clean and colorful, creating an engaging, easy to use interface. And the main program flow is by the file name of the jokes is defined file name. The jokes are loaded using load jokes function as well as display joke function is called to show the first joke setup when the program starts. And the root main loop line starts in the GUI event loop, making the application responsive to the user's actions like clicking buttons. And to summarize, this program creates an interactive and fun environment for the users to enjoy jokes. It handles the loading of jokes from a text file, randomly selects them and allowing the users to reveal the punchline at their own pace. The GUI design is a visually appealing with custom colors and styles. The program also includes error handling and for missing or unreadable jokes. So let's test out the joke teller app. What does the vegan zombie like to eat? Let's reveal the punchline. Grains. Next joke. What do you call a dog that's been run over by a stream stroller? Let's reveal the punchline. A spot. Okay. After that funny joke, let's head on to the student management system. Lastly, the student management system application, which allows the user to manage and view student data, including coursework and exam results. The program uses tkinter for the graphical user interface or the GUI, and CSV for storing and loading student data. For the key functions, for loading and saving data, we have load student data function, which reads the student's record from the CSV file, parsing the student code, name, coursework, and marks, and exam marks, as well as save student data, which writes the data back to the CSV file. Moving on, the calculating results, which includes calculate student results, computes the total coursework marks, exam marks, overall score, percentages, and determine the grade using determine grade, which is this function, which we use if else statement and elif statement to find out the percentages and which grade do they get. Moving on, displaying data, which includes show students functions, which populates a three view with all students' results, showing their total coursework, exam marks, percentage, and grade. For view individual student function allows searching for a student by their unique code and displays their detailed record. As for show highest student and show lowest student, this it displays the students with the highest and lowest scores respectively. And for its design or its GUI layout, the student management system GUI consists of a clean and organized layout with key elements stacked vertically at the top. There's a bold title label displaying student management system. Below the title, a three-view widget shows students' details such as code, name, coursework marks, exam marks, percentage, and grade, with a scroll bar for easy navigation. Underneath is a summary labeled presents the total number of students and their average percentage, which you can see here. The total number of students, which is 10, and the average percentage, 68.31%. And this shows the credentials of the students and the code where you can input here and you can find individual records of students. An input section follows where users can enter a student code to search for individual records. Below the input, a button section offers four functional buttons, which are view all students, view individual students, highest scorer, and lowest scorer. For this one, once you input a code, you can find an individual student's credentials. Let's say perhaps Jacobs. Let's try 8439. 8439. And let's find its individual credential students. As you can see, it shows Jake's Hub with his credentials, as well as view all students, which is this already, and the highest scorer, which is Alan Scherer, and the lowest scorer, which is Garrett Southgate. So the GUI is a responsive and user-friendly updating in real time when the data is changed or new information is entered. The program reads from a file on startup and offers functionality to display, edit, and calculate student data interactively. So that would end off my walkthrough and technical description of my Python codes and Python series. And thank you for listening.